Hello, IB11s. The topic today is 2H, the modulus function. What is a modulus? The modulus is another word for the absolute value. So the modulus function is also called the absolute value function. The modulus of x is, okay, let's look at what is the modulus of 5. We know these two slashes always can make any number to be positive. So the modulus, or we can see the absolute value of 5 is 5. The modulus of negative 5, or we can say the absolute value of negative 5 is still 5. So the modulus of x is x if the x value is positive or 0, like this number 5 here. But if the inside number is a negative value, negative 5 for example, if we remove the absolute value symbol, we need to put a negative sign to show this is a positive number, because like this one, when we take off the absolute value, we need to put a negative sign outside the negative 5. So negative 5 becomes positive 5. The basic modulus function is y equals the absolute value of x, and you will find that, okay, just as what we did here, when x is greater than or equal to 0, this absolute value of x is just x. When x is negative, the modulus of x is negative of x. If I want to graph this one, you'll find, okay, in this function, without the absolute value symbol anymore, you have two pieces. So this kind of function is also called piecewise function. So if I want to graph this modulus of x, I graph these two pieces of the functions. The first piece is y equals x. We know y equals x is a straight line. This is y equals x. The y-intercept is 0, the slope is 1. However, we don't need the entire line. We only need x is greater than or equal to 0 part. So what I will do is erase the negative x value part. For x is negative value, the function is y equals negative x. If I graph y equals negative x, this graph pass through the origin because the y-intercept is 0 and the slope is negative 1. It should be such a straight line. However, right now we have the restricted domain. We only need this line on x less than 0. So what I will do is I erase this part. This V shape is the graph for this modulus function. Of course, this function is also called a modulus function. And it looks like a V shape. Number 4, let's look at a very important property of absolute value of x. The absolute value of x is always the square root of x squared. Let's look at the first example. The absolute value of 9 is equal to the square root of 9 squared. The square root of 9 squared is the square root of 81. The square root of 81, of course, it's 9. So the modulus of 9 is 9. The modulus of negative 3. This one equals the square root of -3 squared. -3 bracket squared is 9. So it's the same as the square root of 9. Root 9 is just 3. So we will know the modulus of -3 is 3. The modulus of 0 is equal to the square root of 0 squared. It's square root of 0. It's 0. So the absolute value of 0 is always 0. Okay, let's look at example 2. If I know A value is -3, B value is 4, find each value. So the first one, the absolute value of 2A minus B. What I need to do is just plug -3 in for A, 4 in for B. So the first one I will get, in the absolute value symbol, I replace this A with -3, and this B with 4. So in the absolute value symbol, or we can see in the modulus symbol, we can get -6 minus 4, which is -10 in modulus symbol. The modulus of -10 is +10. The absolute value of A squared minus the absolute value of -B. A value is -3. Let's plug in. Then squared minus 4. Plug in 4 for B. The absolute value of -3 is 3. Then I do squared. So you guys will see the absolute value, or we can see the modulus symbol, has the same priority as the pair of brackets. If I have the modulus symbol, I always simplify the modulus part first. Then I do exponents. Minus the absolute value of -4 is 4. So 3 squared minus 4 is 9 minus 4. This one is 5. The absolute value of A times B. A is -3. B is 4. -3 times 4 is -12. The absolute value of -12 is +12. Example 3. Write down the following functions without the modulus sign and graph each function. That means we need to get rid of the absolute value symbol. The first one, let's look at how can I remove these two vertical lines. I will use the modulus function definition here. I can change any modulus function to a piecewise function. So here, I will say if x is larger than or equal to 0, I can just remove the absolute value symbol on x. It will become x minus x. Let's simplify x minus x. It's 0. So the first piece is 0 when x is larger than or greater than equal to 0. The second piece is x is less than 0. When x is less than 0, when you want to remove these two vertical lines, you need to put a negative sign for x. So it's x minus -x. Simplify this red one. This one is negative becomes plus x. So it's x plus x, 2x, when x is less than 0. If I want to graph this modulus function, I just graph this piecewise function. So I graph each piece respectively. The first piece is when x is larger than or equal to 0, the y value is 0. The y value is 0. It's a horizontal line overlapping with the x-axis. But right now, the restricted domain is x should be positive or 0. So I only leave this part there. The second piece is y equals 2x. Let's graph y equals 2x. For this one, the y-intercept is 0. And the slope is 2. That means you go up 2, go right 1. If you guys want to scale both of these two axes, that would be great. But right now we only need to sketch it. Let's just estimate the positions. But I hope that maybe you can just scale on both of the axes with some important points. Anyway, the second point is here. Then I can graph the second piece. However, I don't need the whole green line. I only need x is less than 0 part. So what I will do is I erase the positive part. So the final graph is such a horizontal line plus such a oblique line. This is the graph for this modulus function. The same for b. If I want to take off the absolute value symbol, I need to follow what I did here. So first piece should be x is larger than or equal to 0. In this case, you can remove these two vertical lines right away. Leave x times x, which is x squared. So this is the first piece in the piecewise function. When x is less than 0, when you remove this symbol, it will be x times negative x. X times negative x. The second piece is negative x squared when x is less than 0. So right now, I graph each piece individually. The first piece, y equals x squared. It's a parabola function. But right now, you only need the positive part. So this is y equals x squared when x is larger than or equal to 0. And the other part is negative x squared. Negative x squared and x squared, these two parabolas have the opposite direction of opening. So this one opens down. So this one goes this way. So this one is y equals negative x squared, and you only need less than 0 part. So less than 0. You don't need the other part. Let's look at the number c. C is a little bit more challenging because I have two modulus signs in this function. If I have two absolute value signs in one function, I will use a number line to help myself find the boundary points. First, the boundary points comes from this one is 0. This one is 0. When x is 0, this is one boundary point. When x plus 3 is 0, x is negative 3. This is another boundary point. Then you will see negative 3 and 0. Divide the whole number line into 3 parts. So that means if I want to take off the absolute value symbols here, I need 3 pieces in the piecewise function. The first piece is x is less than negative 3. When x is less than negative 3, this one is negative. When you take off the absolute value of x, it becomes negative x. X plus 3 is also negative. So when you remove the modulus sign, you need to put a negative sign in front still. Negative becomes positive. So this one becomes negative x plus 3. Cancel these two x. So this one is 3. So the first piece, I will know that when x is less than -3, the y value is 3. Let's look at the second piece, which is this part. When x is between -3 and 0, you will see this x is still less than 0. So absolute value of x is -x. But this part becomes positive. When you remove the absolute value symbol, you just put down x plus 3 only. Then let's expand the brackets and simplify it. So it's -x minus x minus 3. It's -2x minus 3. So the second piece is when x is between -3 and 0, the function is -2x minus 3. The last piece is x is greater than 0. If x is positive, you know this one absolute value of x should be just x. X plus 3 is still positive. So when you remove the modular sign, you only have brackets x plus 3. Then simplify this expression. It's x minus 3. It's -3. Which means the third piece in this piecewise function is when x is larger than 0, it's -3. In the domain, which is the real number system for this function, we still missed two values. One is -3, the other one is 0. This is a kind of global rule. In most cases, we put the -3 value with this symbol. That means x is larger than -3. We always put it with the larger than sign. So when x equals 0, I put the 0 with this case. Okay, so right now I have all three pieces done. What I need to do is graph each piece individually. The first piece is y equals 3. Y equals 3. 1, 2, 3. It's a horizontal line. But you don't need to continue anymore. Oh, actually, we only need the part less than -3. So here, -1, -2, -3. So that's all what you need. Then the next part is between -3 and 0. The graph is -2x minus 3. This is a linear function. If I scale the negative x-axis as well, the negative y-axis here, it's -1, -2, -3. The y-intercept is -3. And the slope is -2. That means down to right 1. But you also can do up to left 1. So you will find this line look like this one. So this is the graph for the second piece. And the last piece, which is x is greater than or equal to 0. So this one, the graph is a horizontal line again. Okay. So it's look like a Z shape. So this is the graph for this function. Okay, let's continue the topic on the modulus function. Example 4. Determine if the following are true or false for all real values of a and b. Let's look at the first one. The modulus of a plus b equals the modulus of a plus the modulus of b. Is this one true or false? This one is false. Okay, if I want to say this one is false, The only thing I need to do is give myself a counter example. For example, if A value is -1, B value is 2, you will see the left side is the absolute value of -1 plus 2. Using the bad math, you can get the absolute value of -1 plus 2 is the absolute value of 1, which is 1. And the right side is the absolute value of -1 plus the absolute value of 2. This one is 1. This one is 2. 1 plus 2 is 3. That means the left side is not equal to the right side when A is -1, B is 2. So this one is not true for all real values of A and B. Similarly, the second one, the absolute value of A minus B equals the absolute value of A minus the absolute value of B. This one is also false. Let's pick up two numbers. If A is 3, B is -2. With these two numbers, the left side is the absolute value of 3 minus brackets -2. And this value is 5. And the right side is the absolute value of 3 minus the absolute value of -2. And this one is 3, and this one is 2. 3 minus 2 is 1. So we can see that the left side is not equal to the right side. This one is not true for all real values. And this one, this is a very important property of the modular signs, or we can see the absolute value. The absolute value of A times B equals the absolute value of A times absolute value of B. You can pick up any numbers for A and B. The test will always be true. And this one is always true for all real values. This one is the multiplication property for the absolute value. And this one is the division property for the absolute value. More properties of absolute value. The absolute value of x is larger than or equal to 0 for any x value. The absolute value of x squared equals x squared for all x value. The absolute value of x over y equals the absolute value of x over the absolute value of y. The absolute value of -x is the same as the absolute value of x. This one is true for all x values. And this is multiplication property that we just talked about in example 4. The absolute value of x minus y equals the absolute value of y minus x. So in the absolute value, if you want to switch these two numbers around in the minus sign, the subtractions with the absolute value should be equal. Okay, this is a very important part that we need to learn. Solve modulus questions and inequalities. Let's look at example 5 first. How can we solve this modulus equation? The absolute value of x equals 3. We will know the absolute value of 3 is 3. The absolute value of -3 is also 3. In this case, I will know this x value can be positive or -3. So we can generalize this equation. We say this absolute value of x equals a, as long as is our non-negative value. This x value is positive or negative a. This is also the solution for this modulus equation. Right now we need to use this generalization to solve the other two. absolute value equations. Let's look at this one. This one is not a simple x here anymore. It's 2x plus 3 inside the absolute value symbol. But it's the same as x. I will take this one as one family. 2x plus 3 equals plus or minus 7. So here, from this one, you can get 2x plus 3 can be positive 7. Or 2x plus 3 can be negative 7. 2x plus 3 is 7. Let's continue to solve x value. It's 2x equals 4. Divide both sides by 2. Then x equals 2. For this one, it's 2x equals negative 10. Divide both sides by 2. The x is negative 5. So the solutions of this modulus equation are x equals 2 or x equals negative 5. You can plug both of these two solutions into this modulus equation. Both of these two values can make this equation true. Let's look at this one. This one is a little bit different because this side is negative 1. But we know the absolute value of x is always larger than or equal to 0 for all real number values. No matter what the x is, once you put the absolute value on the x value, this absolute value will never be negative anymore. But this absolute value is negative, which suggests this equation has no solution. There's no way for us to find an x value such that this absolute value is equal to negative 1. Let's look at a little bit more complicated absolute value equations. A, B, C. But C, for this case, it's not required in DP course. We can skip this one. Let's look at the first one. This is a rational equation with the absolute value. But anyways, I will take this one inside as the entire family. So this one is 3x plus 2 over 1 minus x equals positive or negative 4. So I will get two rational equations. One is 3x plus 2 over 1 minus x equals positive 4. Or the other one is 3x plus 2 over 1 minus x equals negative 4. Now let's solve these two rational equations. When we solve two rational equations, we multiply both sides by the denominator. So this blue equation will become 3x plus 2 equals 4 times 1 minus x. Then expand the brackets here. 3x plus 2 equals 4 minus 4x. Move negative 4x to this side. Move 2 to the right side. We will have 3x plus 4x equals 4 minus 2. So it's 7x equals 2. Then divide both sides by 7. X equals 2 sevenths. Let's look at the red one. Exactly the same. We multiply both sides by 1 minus x. So we can get 3x plus 2 equals negative 4 times 1 minus x. Open the brackets here. 3x plus 2 equals negative 4 plus 4x. Isolate x term from the constants. So it's 3x minus 4x equals negative 4 minus 2. This one is negative x equals negative 6. Divide both sides by negative 1. X equals 6. So the final solutions of this equation can be 2/7 or x equals 6. Right now, let's look at how can we solve this one. If you have two absolute values in one equation, but without any other numbers involved, like this one we still have a constant at the end. So compare with this one is way easier. Let's look at how can I solve this one. One absolute value of something equals the absolute value of something too. So what I can do is I remove the absolute value. X plus 1 equals positive or negative brackets 2 x minus 3. You still have two equations. The first one is x plus 1 equals 2x minus 3. Or the other one is x plus 1 equals negative brackets 2x minus 3. Let's solve this linear equation. It's x minus 2x equals negative 3 minus 1. So it's negative x equals negative 4. Divide both sides by negative 1, x equals 4. X plus 1 equals negative 2x plus 3. Then isolate x term from the constants. So it's x plus 2x equals 3 minus 1. This is 3x. This is 2. Divide both sides by 3. So x equals 2/3. So in this equation, we also can find two solutions. One is x equals 4 or x equals 2/3. Okay, we still have two examples left in this lesson. Example 7. Solve this absolute value equation graphically. This equation is the same as question C in example 6. But for the algebraic method, it's not required in DP course. But we still need to know how to solve this absolute value equation by the technology. So let's look at how we can use the graphing calculator to figure out the solution in this equation. So I will let y1 be the left side function and y2 be the right side function. Right now, I want to put both of these two functions into the graphing calculator. How can we put the absolute value of x minus 1 into the graphing calculator? So here, there is a function key. We press math, then go to number. It's ABS. ABS means absolute value. Then I put x minus 1 in. Then plus the absolute value again. So let's go to math, choose number, absolute value again. It's 2x minus 5 brackets. And the second function is 2. In this case, the window setting I set up was x minimum -1, x maximum 5, y minimum -1, y maximum 5. Then I graph these two functions. You can see these 2 points of intersection clearly. And the x values of these 2 points of intersection should be the solution of this equation. So right now, I want to take a picture of this graph. For you, you can copy down the graph onto your paper. Then we will follow this function to look for the points of intersection. So the first one, it's on the first curve. It's almost at the point of intersection. So we can press enter. So this one is still around the point of intersection on the second curve. So let's press enter. Then guess. So the graphing calculator can help us find the x value of this point of intersection. This one is 2. Let's repeat the same steps to find the point of intersection here. So this one is second trace, go to intersect. So I will move this cursor towards the second point of intersection. If it's almost there, let's press enter. Then this point will jump onto the second graph. So the second graph is the line. So it's almost there. So let's press enter. So guess it. So you will see the x value for this point of intersection is around 2.67. We have already talked about this one. If the answer is a decimal, we can keep 3 significant figures as the answer. So right now, for y1 equals y2, for this absolute value equation, I got 2 solutions. One is 2. The other one is 2.67. And we found that if we use the graphing calculator, we can solve the absolute value of the equation fairly quickly and easily. So this time let's look at example 8. Solve this one graphically. I will do the same thing. I will let y1 be the left side function and the right side be the second function. So then in the calculator, I will change the first one. Of course, you can clear the first one and clear the second one and leave the space to put these 2 new functions in. So the first one is absolute value of 1 minus 2x. And the second one is x plus 1. So let's graph. I can see both of these 2 functions fairly clearly in the window setting. So that means I don't need to change any values in the window setting. So right now, I will take a picture of this graph. Okay, then let's find the points of intersection. But I only need x value for both of them. So the x value, the first one is, you guys just repeat all the steps as second trace, then find function 5. And you will find that this x value is 0. And this x value is 2. Right now, I have 2 functions. The first one is absolute value function. And the second one is the linear function. And we know the absolute value function should be the V-shaped graph. And this regular linear function is this straight line. So right now, we know this inequality is y1 larger than y2, which means I need to find the x values which can make the graph of this absolute value function above the graph of the line. So you will see the x values can be either here or in this part. So the solution for the inequality should be x is less than 0 or x is larger than 2. And make sure that do not put the equal sign for both of them. It's mainly because in the original inequality, there's no equal sign here. Okay, Here is the practice question. So hope that you guys can practice a little bit more through the homework. If you need any help, please let me know.